So, what you're looking at right here, this little sphere, is arguably one of the most dangerous objects humankind has ever created. In the 9 months right after World War II, this small ball of plutonium was involved in two separate fatal accidents. It earned itself a terrifying nickname, the Demon Core. Today, we're going to unpack the story of those accidents, the brilliant scientists who lost their lives, and how their tragedy completely rewrote the rules for nuclear safety. You've probably heard that phrase before, right? Tickling the dragon's tail? Well, it was the one and only Richard Feynman who came up with it, and honestly, it's the perfect description for what was going on at Los Alamos. You had scientists performing these unbelievably risky experiments, pushing a chunk of plutonium right to the very edge of a chain reaction. I mean, they were literally poking a sleeping dragon, just hoping and praying it wouldn't wake up. And this was the dragon, a 6.2 kilogram sphere of plutonium that had the, believe it or not, surprisingly boring codename Rufus. This core was actually meant to be the heart of a third atomic bomb, the one slated to be dropped on Japan. When the war ended, it didn't really have a military purpose anymore, but its scientific value was just off the charts. So it stayed at Los Alamos for a series of what would become vital and ultimately deadly experiments. Let's geek out on the specs for a second. It weighed just 14 pounds, and it was stabilized with a gallium alloy. But the truly chilling detail here is that last line, initial reactivity, -5 subcritical. So what does that actually mean? Well, in simple terms, its safety margin was razor thin. A tiny little nudge, just the wrong placement of some reflective material nearby, was all it would take to push it over the edge into a lethal, uncontrolled chain reaction. And this really drives home just how deceptive this thing was. 3.5 inches in diameter. That's about the size of a softball. You could literally hold it in one hand. And yet this small, warm sphere of metal contained enough raw power to level an entire city. Its tiny size completely masked its unimaginable potential for destruction. The first tragedy struck on August 21st, 1945. Think about that. Just 6 days after the war had officially ended. A 24-year-old physicist, Harry Daghlian, was at a remote Los Alamos site doing one of these dragon-tickling experiments. He was working late, and he was working alone. Okay, so the concept of the experiment was simple enough. Daghlian was stacking these heavy tungsten carbide bricks around the core. Now, these bricks act kind of like mirrors for neutrons, bouncing them back into the plutonium to nudge it closer and closer to going critical. As he moved to place the final brick, his instrument started screaming a warning. This was it. This was the one that would wake the dragon. He pulled his hand back, but he fumbled and dropped the brick right onto the core. Instantly, it went supercritical. His immediate and really heroic instinct was to physically knock the stack apart with his bare hands to stop the reaction. In that one brief flash, Harry Daghlian got hit with a massive whole-body dose of 510 rem. Now, to put that number in perspective for you, a dose of 400 to 450 rem is considered lethal for about half the people who get it. The dose to his hand was astronomical, probably in the thousands of rem. He would die 25 agonizing days later from acute radiation poisoning. You'd think one death would be enough, right? That it would change everything? But just 9 months later, the very same core claimed its second victim. This time, it was Louis Slotin, a brilliant 35-year-old Canadian physicist who was known as the lab's foremost bomb put-togetherer, and he was demonstrating his technique to 7 other people in the room. And this is where we see the fatal difference between protocol and practice. The official procedure, the stuff you see on the left, it demanded using shims, little spacers that made it physically impossible for the 2 reflector halves to fully close. But Slotin, who was known for his bravado, he had his own unapproved method. He used nothing but the blade of a flat-tipped screwdriver, relying entirely on his own steady hand to keep disaster at bay. And then, as 7 observers watched, it happened. The screwdriver slipped. Just a fraction of an inch, that's all it took. The heavy beryllium shell dropped, completely enclosing the plutonium core. The dragon woke up. And just like Daghlian, Slotin's reaction was instantaneous. He ripped the assembly apart with his bare hands, flipping the top shell onto the floor. It all happened in less than half a second, and that single action almost certainly saved the lives of everyone else in the room. But for Louis Slotin, it was already too late. Everyone in the room saw it, a brilliant, silent, blue flash. For a long time, people thought this was something called Cherenkov radiation. the kind of glow you see in underwater reactors. But the physics doesn't really work for that in open air. The scientific consensus now is that the flash was caused by the intense burst of radiation itself, which violently stripped electrons from the nitrogen and oxygen atoms in the air. Pretty much the same physics that causes lightning to glow.
I mean, when you put the two accidents side by side like this, the parallels are just absolutely chilling. Both were triggered by a simple manual error, a dropped brick, a slipped screwdriver. Both were met with the exact same immediate, heroic, and ultimately futile physical intervention, and both unleashed a terrifying number of atomic fissions in less than a second. The accidents themselves, they were over in an instant, but their consequences, they played out over days and weeks in the most horrific way imaginable. This next part is pretty grim, but it's essential to understanding the true cost of these experiments and the brutal reality of what acute radiation syndrome does to a person. Louis Slotin's decline was terrifyingly fast. He received a dose of over 1,000 rad. After the initial sickness, he actually seemed okay for a couple of days. But then, by day 4, his body just began to shut down. His intestines stopped working. By day 5, the doctors described a total disintegration of bodily functions. His white blood cells and platelets just vanished, and he started to bleed internally. By the 9th day, after suffering through delirium, Louis Slotin was dead. And if the story wasn't heartbreaking enough, get this. In a final, tragic turn of fate, Louis Slotin died in the very same hospital room, and reportedly in the same bed where Harry Daghlian had died just 9 months before. I mean, that detail, more than any other, just highlights the failure to learn, the persistence of a culture that allowed a nearly identical accident to happen a second time. Now, Slotin's quick action saved everyone else from an immediate fatal dose, but the radiation still left its mark. This table shows what happened to some of the other people in the room. Alvin Graves, he was standing closest, died at 55. Others developed cancers consistent with radiation exposure, like leukemia. And yet, look at Raymer Schreiber. He lived to be 88. It's just this stark reminder of the random, terrible lottery of radiation damage. The death of Louis Slotin was the final, brutal wake-up call. It was the end of what some people called cowboy physics. The director of the laboratory immediately halted all hands-on criticality experiments. The Demon Core had claimed its last victim, and in doing so, it forced a revolution in nuclear safety. And the shift was, well, it was night and day. Before, you had a scientist literally holding the experiment in their hands, in the same room. After, the entire philosophy changed to getting the human out of the equation. The new mantra was distance and automation. Now, the operator would be sitting a quarter-mile away, safe inside a concrete bunker, watching the whole thing on a television screen. And these are the machines they built to do the job remotely. With the pretty curious names Topsy, Lady Godiva, and Jezebel, these devices used hydraulic rams and remote triggers, but crucially, they were designed with automatic scram mechanisms. So now, if something went wrong, the only damage would be to metal and glass, not human flesh and bone. But the dragon, it seems, never truly sleeps. The lessons of the Demon Core have to be constantly relearned. And you're not going to believe this, but as recently as 2011, at the exact same lab, another near-miss criticality accident happened. And why? Because technicians foolishly placed plutonium rods too close together just to take a photograph. It just goes to show you that complacency will always be the greatest danger. So what do we take away from all this? The story of the Demon Core is a powerful cautionary tale about that thin line between genius and hubris. The deaths of Harry Daghlian and Louis Slotin were absolutely not in vain. They led directly to safety protocols that have saved countless lives since. But the question they leave behind is one we still have to ask ourselves today. When we're pushing the boundaries of what's possible, how do we make sure we never, ever forget the lessons that were paid for so dearly in human lives?